सर्वे भवन्तु सुखिनः, सर्वे सन्तु निरामया, सर्वे भद्राणि पश्यन्तु, मा कश्चित् दुःखभाग् भवेत्. Om Shanti Shanti Shanti. Good morning, distinguished guests, esteemed speakers, and dear participants. I, Professor Hirva Popat, welcome you all to the first international conference on advances in smart computing and applications. Today marks the beginning of an exciting journey of knowledge sharing and collaboration in the ever-evolving field of smart computing. We are gathered here today to explore groundbreaking innovations, discuss emerging trends, and push the boundaries of what technology can achieve in the modern world. Today, to set the tone for this prestigious conference, we are honored to begin with an insightful keynote address by a distinguished expert in the field. I would like to invite Dr. Prerna Agarwal to welcome our first keynote speaker of the day.
A very good morning to all dignitaries, esteemed guests, authors, listeners, and faculty members, and dear students. Today we have with us Dr. Rajkumar Bhuya from Melbourne, Australia, as our esteemed keynote speaker. Dr. Rajkumar Bhuya is a Redmondberry Distinguished Professor and Director of the Quantum Cloud Computing and Distributed Systems Laboratory at the University of Melbourne, Australia. He has authored over 850 publications and 7 textbooks, including Mastering Cloud Computing, published by McGraw-Hill. Dr. Bhuya is one of the highly cited authors in computer science and software engineering world. Dr. Bhuya is the recognized highest cited author in distributed computing field worldwide. He graduated 60 PhD students who are working in the world-leading organizations recognized as Microsoft, Google, and IBM. He has been recognized as IEEE Fellow, a Web of Science highly cited researcher for 7 times since 2016, the Best of the World twice for research fields, as well as Lifetime Achiever and Superstar of Research in Engineering and Computer Science by Australian Research Review. Today he will be discussing about neoteric frontiers in cloud and quantum computing. Thank you, sir. Over to you.
Can I start? Okay. So thank you for inviting me to be part of this conference to present keynote talk. And of course, I appreciate your kind introduction. Very nice to see this assembly of colleagues interested in this area of computer science. And today I'm going to talk about some of the recent advances within the computer science. The two prominent areas are cloud and quantum computing. Then obviously they are driven by requirements of real-world applications such as big data, IoT, and of course AI too. So these are the applications that need such capability. And so they are actually pushing a lot of advances in these areas, and which is what we'll discuss today. Then if you look at some of the top technology trends, and you hear a lot of people talking about, for example, AI. So often what they mean is application of AI in solving real-world problems. So that is the first one. And even some of you probably heard just a few days ago, Modi visited France, where they had a AI summit talking about AI and its potential impact on different aspects in economy, in business, in science, society, and so on. So that application, so that is one area. To power this AI application, so we have what we call cloud computing and also quantum. So without, for example, cloud computing, AI ubiquitous applications would not have been possible. So this is the power of cloud computing, not just AI application, but also enterprise applications, other government applications. There are many, and then consumer applications, social applications. There are many applications that are already running on cloud. So therefore, it is important to take a look at the foundations of cloud computing, then its applications. With that, here's a brief outline. I will give you how this computing paradigms evolved and focus on cloud computing, then some of the recent trends in this area, and how the field has evolved during the last 10 years, then what is the future. So then we look at briefly cloud architecture, we look at how do we build application that can scale large scale to support millions of users. So I will illustrate that with one of the platforms that we developed. Then we take a look at quantum computing. So we have an initiative at Melbourne University, Quantum. So we'll study briefly, discuss briefly the foundations and two of the technology that we developed. Of course, this field is rapidly emerging. Then we conclude at the end. So this is the outline. So let us move ahead with the first one. And you all know that there are different computing paradigms, emerged since 1960. So starting with mainframes, move forward. So here is the web 25 years ago, almost as a way of accessing remote information. But in the name of web, we have saw the emergence of what we call service-oriented computing. So thereby, instead of accessing remote information, we can make application interact over the network. So made possible through web services. That's what we call realization of service computing. Furthermore, led to the what we call virtualization, wherein we can have capabilities as a virtual services. That led to the emergence of cloud computing, which is like making computing as a utility, just like electricity, water, gas, telephone. They have become a subscribed service. Similarly, computing becomes a subscribed service. That is what cloud is made possible. Then obviously in between there are other emerging technologies such as Internet of Things. So not just networks, but networks of everything. So for that application support, cloud was the dominant. Nowadays there is also need for having real-time IoT. So here also came into picture. In between them, so we also have quantum. So quantum is the new computing paradigm, computing technology. So which can help solve some of the problem much better, much faster, especially for example AI. AI applications consume enormous amount of computing power, which means enormous computing of electric power. So therefore we need to have a sustainable AI, so that can be made possible through quantum integration into the cloud. So our talk primarily focuses in this triangle. And these advances in the past were heavily driven by requirements of applications from scientific, military, but today they are driven by requirements of big population. So this population, country like India with large population, so how do we create necessary technology solutions, IT for the masses? And so if you look at cloud computing at a glance, so here what we see is cloud offering what we call subscription-oriented services. So as a user, no need to buy hardware software. You simply subscribe to these services, use it, and pay for what you consume. So therefore, you can see the notion of what we call cloud service provider. We've got ISP, internet service provider, telephone service provider, similarly cloud service provider. So these service providers, somewhere in the network, we don't need to know where they are. So they have set up necessary compute capability, application capability, storage capability, to which you can subscribe as a user, subscribe it, use it, then you use as much as necessary. Then after that, you pay for what you consume. This is a pay-as-you-go based model. So even though you may subscribe to one service provider, that actually they are using capability from other providers. This is 2, this is 3, multiple providers put together and deliver services to end users. So this is how cloud computing has, becoming so pervasive. And this pervasive model has many applications, and successfully the enterprise applications such as CRM, customer relationship management, ERP, these are now available service at a small price. And more importantly, not only scientific, but also this consumer application. So the large user base worldwide. So they are benefiting a lot. So for example, things like WhatsApp is a cloud-hosted communication, like a Zoom that we are using today is a cloud-hosted video conferencing software. So we are connecting, you can see I'm in Australia, all of you are in Gujarat, and we are connected, and went everything so smoother and without any complex technology requirement. So this is cloud-hosted thing. If you are not, otherwise you'll have to set up a big facility yourself in your place and also in my place, then connect. It's very expensive only. That means only few people can afford. But in the cloud model, very easy, so very affordable. So then moving forward, storing content in a store cloud. So through, for example, Dropbox, social network application like Facebook and Twitter, X. Then of course now natural language processing. So query answering systems such as ChatGPT. So these are all applications running on a cloud. Without cloud, all these applications would not have been possible. Okay, so that is the success of cloud computing. Of course, this cloud computing is not so, quite recent. So initially it emerged a little bit story as a virtualized environment. So that is made possible in 2008 through virtual machine. So then, of course, there were technologies to enable virtualization of our servers. Then as we move forward from 2008 to, say, for example, 2025, and you see different concept also introduced. For example, containers. Rather than having application physically deployed on each of the VMs or physical machine, but why don't we just create a package called container and we can deploy that easily on different virtual machine. And to enable that, there was something like Docker technology available. Then as we move forward, software-defined networks to virtualized network also. So then up to this point, of course, it was the necessary, it was the responsibility of programmer to do resource provisioning. Now that responsibility shifted to others. It is made possible through what is called as serverless computing. So then, of course, nowadays we have a lot of discussion about this quantum. So this quantum also as a cloud service. We will discuss about this as we go along. So that is how the technology evolved and concept and technology evolved. And also similarly to there are lots of vendors, companies have built different solutions to support this. If you go back to 2010, at that time we just had a 3-layer architecture. This is layer 1, then the PaaS and infrastructure. That's all. But now we have got introduction of, for example, this PaaS, function as service. So this is the realization of serverless computing. So that means the responsibility of creation application is just with the developer, but after that, the deployment, management of that application, offering collaborative service are shifted to the lower layer layers. So this way, productivity of software engineering can be achieved. Then coming to the research domain, how do they do? So one is doing all experimentally with real application, real hardware. Second can be modeling and simulation. So here is, for example, a tool called modeling and simulation. So we developed this cloud sim in 2008 itself. We released when this concept of visualization was there. And as the different concept evolved, accordingly, cloud sim also has been extended to include all these capabilities. For example, cloud sim, serverless computing. And also with the emergence of quantum, we added quantum to cloud sim. And recently we released the new version of cloud sim, which is called cloud sim 7G. So you can see this is a technology used by numerous people around the world, not just university people, but also industry. Say, for example, Ericsson. Ericsson uses this cloud sim for modeling, mobile data center services. IBM uses this for modeling, business cloud. So it's very successfully used by businesses as well. And some of those people earlier who use this cloud sim, for example, from IBM, so they were just research scientists, but today they have become CTOs of IBM. So this is the success of their use. So meanwhile, newer technologies are coming up to meet requirements of trustability. For example, how do you build trusted services? So that can be made possible through integrating blockchain. So then, and how do we enhance large-scale scalability of application? For that, we need a microservices-based software engineering. These are the concepts, but how do we realize it in real world? So that requires much more advances. And parallelly, applications, many types of applications. The applications from the social network that we already saw, scientific, business are there. But now with AI, popularity, AI applications also on the cloud. So what are those? So for example, some healthcare application on the cloud. So we will discuss some of these. Then natural processing like ChatGPT on the cloud. Then of course some surveillance, security application in the cloud, industrial automation, then agriculture. So there are many applications that involve use of AI techniques. So therefore, this here is the cloud that is further enhanced to support this. And we will discuss those now as part of the application of this technology like Aneka. So that is in brief. Now, how all these advances impact on the architecture of cloud? So this cloud architecture is also evolving with time. Now, of course, we have GPU comes. GPU of course have come. Then quantum processing units, they all come. So they become part of the cloud. So at the bottom, you got physical hardware that interconnected. Then at top, you have got users. When users make a request to cloud, there is what is called administration control. So with administration control, finding out what is expectation of user, are we able to satisfy their expectation? That is called quality of service requirement. Then if you agree to it, then becomes service level agreement from the service developer perspective. So for a given request, let's say you created a virtual machine, these virtual machines have to be mapped to physical machine. So that depends upon structure and type and communicability of that application. So let us say we somehow provision to virtual machine on which we are running application. And then of course, initially just few users. With time, number of users increase from let's say 200 users to 20,000 users. When you have 20,000 users, you try to serve them, then we need to make sure that we provision right amount of capacity so that their requirements can be met. So this is called elasticity expansion. Then when the demand decreases, at the time you shrink the allocation. This is called dynamic provisioning, deprovisioning, and provisioning elastically to meet user requirement. So having such a model, there are many benefits. So what are those? First benefit can be, for example, the resources that are there, we can use efficiently. Then of course, because we are leasing this capability, so we only pay for what we hold on to, what we lease at that time. Accordingly, the cost efficiency can also be assured. Then plus, but because we are using resources in a wise way, so we can also achieve energy efficiency. This cloud data center consumes a lot of energy, electric power to power them. So therefore, we can reduce that consumption and make them much more power efficient, energy efficient. So these are the achievements of such approach. Now the question is, how can we build applications that can also scale like this, scale out, scale in? Okay, so that is the next challenge. So let me introduce this Aneka from that perspective. Okay, so now coming to application programmability. Engineering applications that can scale dynamically across multiple resources easily. So here is the technology called Aneka, is a cloud application platform for building elastic applications that can scale. And the environment should also be able to deploy those application components seamlessly based on resources that are allocated. So for that purpose, this Aneka comes with two key components. The first one is SDK, software development kit, that has various types of APIs, application interfaces, using which you can build application, and there are tools using which you can build applications. So for example, there are models like thread model programming, task model programming, map-based model programming. These are different ways of creating cloud application. And once you build those applications, you can deploy either in a private cloud or a public cloud seamlessly using Aneka's runtime machinery. So this platform is very unique. It's a world first platform able to support multiple models of programming. And how is this made possible? This is made possible through what we call service-oriented content architecture, under which some of the key services are hosted. And these services are used to create task model, thread model, MapReduce. In the future, the new model comes up, you can implement it. And so then, as I said, you can deploy private, public, or multi-cloud in a seamless manner. So this is a very unique approach that we have. So recently we licensed this Aneka technology to many companies around the world. So this technology itself has evolved, since early days of cloud computing. Today we got Aneka 6 latest, so which is focused very heavily on providing, supporting AI application, of course, which means deep learning, machine learning, NLP, and IoT. So these are the applications today I like to highlight, apart from one or two earlier applications. So in this system, in terms of programmability, programmability is very easy. For example, in a cloud environment, we provision a couple of resources on which Aneka worker company is running. Then users like to build application, deploy. For that purpose, let us say about one simple task. Then in your organization, let's say you got 1,000 cameras deployed across campus. You want to create a security application to see, to make sure that everything is happening, campus is secure. So therefore, what do you do? So detect any suspicious activity. So in this case, you might just simply do for I equal to 0 to n, that is n is 1,000. So that's it. So each of the camera data becomes one task processing. So camera 1 data to task 1, camera data to task 2, like they're distributed and processed in real time. You can see the state of the campus, security, everything in real time. And here, as a developer of application, you don't have to worry about how many machines you need, where to deploy them, how to get the quality of service. All that is responsibility of Aneka. You define the service quality requirement, Aneka will take care of the rest. The programmability is also made easier. So to illustrate the resource allocation, for example, here is one data coming from a camera. So for example, we can split that content into multiple segments. So let's say 9 segment, each of this becomes, image segment becomes Aneka thread. Then system provision required resources, then perform computation. Then after performing, then processing of those tasks, then you send back the results to the user. Then of course, then it is presented to the that application. In this case, I applied emboss filter. Then, so this image has now turned into emboss. You can see a 2D image look like a 3D emboss. Then meanwhile, whatever resource we allocated, they are cleared, correct? So this way we don't have to worry about paying for resource unless we need them. So this is the model called dynamic autonomic management of resources. And this Aneka technology used by many users worldwide. So starting from China, Railways Corporation, then of course in India, ISRO for satellite image processing, in places like USA for medical data analytics on the cloud. Then recently there are all this IoT, NLP, machine learning. These are all other applications. So let us take a look at some of these a little bit in depth. So here from China Railways Corporation, these are different design scenarios. You want to find out what is the best scenario for your requirement. For that purpose, they use software called Maya, and then they were doing on a 4-core or 8-core server. And this was taking anywhere between 24 hours to 80 hours. So to reduce the time to discovery, so they've set up a private cloud using Aneka. So we have Design Explorer tool using which they're able to compose this is SPMD, single program, multiple data, single program, multiple data model programming, with which they're able to run. Then when they do it, so on this small scale Aneka-based private cloud inside the organization enterprise, so they're able to do the same thing in 2 hours. So this is reduce that time from 80 hours, 4 days to 2 hours. Now, sometime you might say, oh, there is urgency. I can't wait for 2 hours. I need result in 10 minutes. So here in the system, you can set deadline. Deadline is 10 minutes. It's a deadline. Then, of course, you want to use your local resource takes 2 hours, but you want answer in 10 minutes. What do? You can rent extra resource from the public cloud services offered, which may be hosted and available from Bengaluru, Delhi, or Melbourne. So therefore, you can set a budget limit. Budget is equal to, for example, rupees 50 rupees. Given a deadline of 10 minutes, budget 50 rupees, Aneka on we have looks into cloud services, marketplace, what is the prices, according to rent them, move computation, and bring back the result and achieve that. So this is the market side. I'm sure the people of Gujarat know how the business works. So you pay for the quality they are expecting. So therefore, and the timeline. Suppose if you relax deadline from 10 minutes to say maybe 20 minutes, at that time perhaps you can maybe get it done for 40 rupees. So system operate just like in real world how we operate. So that is China one. Of course, India is one. So in interest of time, I skipped. But now coming to healthcare, it is very important. So there are sensors such as body area sensors. Even the watches are becoming sensor, smart digital watch, electronic watch, and then these data from the watch or sensors like this. So ECG, electronic heartbeat data. So you can send it to mobile phone. From mobile phone, send it to the cloud. So here is ECG as a service running on a cloud built out of Aneka, running on some public cloud or a private cloud. So the users with criticality, different medical users. Some users in emergency might say, give me answer in 2 minutes. Those who are relaxed want to see how their health doing, or give me answer in 24 hours. So such requests coming in, the system is able to allocate such that those can be met. So this is how we did it, and of course, this was one demo covered several times. Nowadays, they're becoming already real world. So initially, this was the first version we did 10 years ago, but now you see everywhere such things. So this data coming in to mobile phone, from there, send it somewhere in the cloud, everything is done. After pressing results come back, and here you see that graph. Just by looking at the graph, you can tell a lot about person health and condition. You can even apply for mental health, mental condition determination dynamically just by looking at the person. So are they happy? So like that. So application in many domains. So next coming to AI application. So in particular in AI, people talk about three things. Usually one in natural language processing, the second machine learning for prediction, third deep learning for detecting pattern or objects. So here is an example of deep learning application in the cloud. So you got different cameras and the camera data is coming in, and you want to identify object of interest. So for that purpose, there are deep learning programs are there, deep.py, AOLO, like that. Some ready-made programs are there, and we can cloud enable them. So that way, when deal with large number of data coming from large number of devices, drones, cameras, and so on. So here is this week, IIT Delhi researchers have created this application using Aneka, and as a result, this became cloud enabled. So, for example, this is the input from the camera over there. Then after processing in real time, then it comes back with output, able to identify how many keyboards are there, how many displays are there, how many monitors are there, how many mouse are there, how many students are there, is there anything missing. So this is how you can do interesting deep learning application. So this can be put it in, such things are already, those of you who visited big places like Mahakumbh Mela in Prayag, there so many cameras are there in so many places for possible observation or maybe crowd control. Sometimes of course things don't go well, but the planning purpose. So all this data can be dynamically real time find out, and manage it. So this is very important. So this is an example of such application. Hopefully some of you who are attending conference have personally visited Prayagraj for Mahakumbh Mela, dipping in the Triveni Sangam area. Okay, so that is the first one, which is deep learning based. Next, let us look at two NLP, natural processing and machine learning. So these two. So what is the natural language processing in this case? As you know, during this COVID time, 2020 to 2022, during the period of 2 to 3 years, so many research papers are published. Most of them were in the context of COVID. Medical papers, computer science paper, they all are using some kind of COVID inspiration. Even people working on sensors, cloud, mobility, they want to social distancing management. So there are thousands of almost more than 500,000 papers published. And if you are someone want to find out what is the best vaccine for the new variant of COVID, going through these millions of paper is not possible. So therefore, why don't we process and then get a query in real time? So here there is a COVID data set. This is COVID open research data set 19 challenge. We took the data set and processed and then took Aneka and created a ML model training on Aneka. So we did that and then data process and kept a. So this way, when the query comes in, we can answer very quickly. So for example, if you just provision one server with 50,000 research papers, part of this data set, then analyzing the data set can take something like say 30 minutes on a single server. Within an acre, if somebody says, please give me answer in 3 minutes instead of 30 minutes. So you define such a requirement. Then Aneka looks into, okay, in this case, I need to provision more servers more services so that I can deliver this. So this is an example illustrating with 4 server, the time reduced by almost 4 or 5 times. So this way, timely delivery. So we're illustrating NLP processing and on the cloud for a practical thing. This is something we also did in at that time, like 2020, late 2020. So we published a paper. You can see so now we got ChatGPT getting popular. So that is an example of NLP on the cloud. And here, this is also NLP on the cloud well before this ChatGPT become popular. So you can see, so these applications illustrating how you can enable the application in the cloud and using Aneka-like system. So this technology is available, as I said, latest version 6 from Microsoft. This is our startup company. We founded in 2008 and 9. So over a period of time, so has evolved, and today we got, and you can explore, for example, download the software and explore. And so this software is also used for teaching courses in cloud computing worldwide. For example, in India itself, numerous universities are teaching, this using Aneka, not only teaching theory but also teaching practical concept. In Gujarat, for example, NIT Surat, so there they got our Aneka also, where people are able to not only learn the theory concept of cloud computing, but also hands-on experience in application programming using Aneka. And this technology is deployed across all the way from Kanyakumari to Kashmir, correct? So in India, it is a fashion. Whatever you want to do it from Kanyakumari to Kashmir. Not just that, also from northeast to a place like Maharashtra. So we got many places this Aneka deployed, including place like, for example, this Maharashtra place, Kolhapur. So various places this is being, used to teach practical experience for students. So this is about cloud computing. So now quantum, the quantum computing getting popular, but this quantum is also through cloud. So let us discuss about quantum. Then of course quantum is now also very big, just like AI, even more hotter. So there is a national mission on quantum computing. So this, up to 2030. So just begin in India. So this was announced at that time, but now is in extent. So you can see this quantum computing in India itself. So a lot of aspects being looked at. So one of them, for example, having a high precision clocks based on quantum. So then quantum communication. So for example, applying for satellite. As you know, India is launching so many different satellites, moon mission, that mission, this mission. So to be able to communicate faster than today. So they're looking into quantum communication. So here is a quantum communication. These are interesting areas why quantum is looked at as a big national mission. But why do we need quantum computing? This is a very fundamental, mainly because some of this today's computing system, even the supercomputers, are not able to support some of the complex problem. So therefore, quantum is promoted. So if you, for example, if you have some big simple thing like large integer factorization, so if you use a traditional system, so with a big machine, it can go like this. Whereas quantum, you can quickly decide exponentially. So therefore, quantum will be helpful. So this quantum, if you want to know conceptually what the difference, how is it different from today's model? So this is the model of classical digital computing. So we have this, we calculate with a transistor, wherein the state is represented by either 0 or 1, correct? Whereas in quantum, you can have both states, 0 and 1 at the same time. That means if you got a quantum computer with, say, 16 qubits, so they call qubits instead of digital bits. Qubits, 16 qubits, you can perform millions of operations at the same time. So therefore, so the huge speed increase. So this quantum is right now suitable mostly for optimization kind of application. But of course, as time progresses, application can increase in different areas. So you can see this is a new approach. Now, but programming these quantum computers is very rudimentary, very primitive, just like punch card programming for mainframes in 1960. So here there is something called circuit programming, quantum circuit programming. So let's say you've got a 10 qubits quantum computer. So these are the 10 qubits, like this, 10 qubits. And then, so the data is coming in. You need to, just like we to do what we call gate programming, AND gate, OR gate, NOR gate, XOR gate. You can place on the line different type of gate, AND gate, OR gate, appropriately. Then the circuit, for example, this is a circuit for random number generation. Like this, you may have to build, you need to build different circuits, algorithm for that quantum application. So therefore, quantum programming is very complex and harder. On top of it, when you transform the circuit into a high-level language, then different quantum hardware providers such as IBM, they have their own way of doing, Google have their own way of doing, Microsoft, they have own way of doing. So that makes programming even more complex. So we are doing research at Melbourne University in our lab. So in our QCloud lab, quantum cloud computing distribution system lab. So wherein, for example, I like to highlight just two technologies. One of them is called QFAS, This is a quantum functional service. Just we talked about the serverless computing model. So we created a serverless computing model for quantum. I will discuss that. And the second is the simulator, modeling and simulation. If you don't have access to the real hardware, so should we wait for it? No. You can do modeling and simulation and carry out your research, publish papers. So there is a second technology. So let me illustrate both of these very briefly, then we conclude. So this QFAS quantum functional service, functional service for quantum computing, wherein, for example, as name indicates, user can create application as made up of a set of functions, and the functions can be quantum function, it can be classical function. So if you build such an application, you submit your QFAS core engine. So this core engine will look into, oh, what type of function is this? Okay, if it is a quantum function, run it on a quantum hardware. If it is a classical function, run it on a classical hardware. So this, and of course, the different hardware have got different interfaces, different way of presentation. So those things are taken care through our layer, adapters, and abstraction. So this way, application developer can simply focus on function composition, leave it to the QFAS. So what are the benefits by this model? We can simplify the process of quantum software development. Then we can solve the problem of vendor lock-in. This way you can do hybrid. It's quantum classical integration. So this is the technology that we built. So that is the practical, build practical application, doing a practical hardware. So, but that is maybe not available to everybody. These days, even hardware research is going on. Even if it is available, it may be just small scale, something like 32 qubits quantum computer. Suppose you might imagine, I want to simulate, I want a quantum computer, so 1024 qubits. How much time it take my application to run? So this is your question, or what is the best way of provisioning these resources? That you can do this modeling simulation. So we created QPU, quantum processing unit, model, and you can model wherein you can express how many qubits are there. So these are what is the topology of different, and what is the error rate. These are some of the quantum parameter. So this way you can create multiple server. Let's say this is quantum server 1, server 2, server 3. Inside you can have QPU, a CPU, GPU. So that's the servers. So then you have to create quantum application. Application, as I mentioned, quantum circuitry programming. So you express that in terms of how many qubits, how many layers, what is the gate set arrangement. So what is the quality of the expectation? Given these two, now you can think of how do I map quantum application to quantum hardware. This is a question. So this can be such iQuantum or simulator can be used to do those studies. Okay, so doing performance modeling and simulation. Or you might create a quantum application. Assume, let's say you create a quantum application with assuming that having a number of qubits as, for example, 10,000. But the hardware available is only 1024 hardware. So how do you map that such large-scale quantum application on a small-scale hardware? So how do you do that? That requires what is called circuit cutting. So you cut into small pieces and map it to different small-scale hardware, and then combine. So this concept of mapping, how to do that. So you can do such studies using iQuantum Simulator, which is available as open source software. You can download from our website. So with that, let me conclude. I talked about emergence of computing paradigms. Today, cloud computing is the one which is making this concept of computing as utility real. So it's already real. So exciting business application, consumer application. So as a result, that concept has become real, not a dream anymore. So then we talked about Aneka, cloud architecture, Aneka. In Aneka, we discussed about how we can reduce the programming time, productivity, increase the productivity. Then when you deploy in a cost-efficient manner. So we saw a couple of applications, particularly AI-oriented application was being discussed, but many more applications. Then coming to quantum is also emerging rapidly. So big missions are there. In Australia, we've got National Quantum Mission. Like that, China has National Quantum Mission. America has Quantum Mission. Europe has Quantum Mission. Everybody has now mission. So maybe next around 10 years, you will have much more reality. So, but right now, it's a lot of big research happening. So therefore, we have been exploring philosophy already. So we release these two tools for the community and industry people to benefit and advance the speed, help advance the frontiers in quantum computing. And of course, learning more for cloud computing, for example, this is a Mastering Cloud Computing book, American edition, almost costs $100. So, but for India, so this is our first edition. Just now we released the second edition of our book. This is around $6. Okay, very affordable. So the same book, but India edition. But the latest edition covers topics this what we call AI, big data, and IoT application. So very explicitly. So we recognize these are emerging area. So that we should be able to do those programming and deploy on cloud. So this is the same thing in Chinese. Chinese language book also available. So for Chinese, it is almost something like $4. Very in China more cheaper than India one. Affordable to everybody, large population. So that's about quantum and cloud. So and here are my contact details. So to connect me for research, if you want to set up a cloud lab using Aneka, you can connect me with this Androsat email ID. With that, let me stop here. I'd like to thank all of you for hearing patiently. So now I'll be happy to take any questions or comments that you got. Thank you.
On behalf of JLS University, I extend my heartfelt gratitude to our esteemed speaker, Dr. Rajkumar Bhuya, for sharing an insightful and inspiring words with us today. Dr. Rajkumar Bhuya is very well known for one of his famous books, Mastering in Cloud Computing. Sir, uh, we have learned the core concepts of cloud computing from your book only, and you are the first chapter of cloud computing in the lives of many students. Your expertise and wisdom have truly enriched our understanding. Thank you for your time, knowledge, and valuable contributions. This session has been both enlightening and memorable. Thank you so much. Sir, there is a question from our audience.
Yes, please go ahead.
Mike? Yeah, Mike. No, I guess. Yeah, sure.
Good morning, sir. Sir, we are using various tools like big data for big data analytics, no, like Databricks, then Cloudera, Hortonworks, and so on, right? Now, since I'm taking this course since many years, now my question is that how Aneka is different compared to all these existing platforms? Can we use Aneka in place of Databricks and some other platforms?
Yes, let me answer. So some of these tools which are oriented just for big data, so they are providing very specific APIs for big data application. Okay, then that cloud is not only just for big data application, but also for IoT application, for machine learning application. Of course, this broadly into big data. Then how do we do that all together? So Aneka is a general purpose platform supporting not only big data class application, but also IoT and also supporting different ways of programming, thread model, task model, MapReduce. Plus, someone has a new idea on, for example, creating a new model of programming instead of what is already there. Say, for example, quantum computing. So quantum computing model of programming is right now is very, very primitive, and you come out with new approach, new abstraction, and you can implement out of Aneka, then you can deploy. And to deploy, you also need to be able to write the scheduler. So Aneka provides you APIs using which you can also create your own resource management scheduler to deploy that quantum mixed application. So this is a very extensible platform. So as a result, many are using worldwide for teaching and learning. and research purpose. Yeah. So it complements, for example, other one you might have heard about Hadoop. So Hadoop supports only MapReduce model programming, whereas Aneka support task, MapReduce plus other design tools and tools. So there is a comprehensive nature. Yeah. So the extensibility, then programmability, then ability to create different things, plus very great tool for teaching and research.
Thank you so much, sir. I think that is I mean, there is a good replacement of no other tools with Aneka, right? So we'll touch upon that, and maybe if required, I will connect with you, sir. Thank you so much, sir. Yeah.
Good morning, esteemed guests, respected dignitaries, distinguished speakers, and my colleagues and all the brilliant minds gathered over here. On behalf of the Faculty of Computer Application and IT and Faculty of Engineering and Technology, I, Professor Hirva Popat, welcome you to the inaugural session of the first International Conference on Advances in Smart Computing and Applications. Now, doesn't it sound visionary? It does, right? Believe me, we are about to set off on a journey that will feel like the teaser for the next big revolution in technology. And what's particularly special about today is the proceedings of this conference will be published in Springer CCIS series, a renowned platform for academic research. And that's indeed a proud moment for all of us. When we say intelligent future, we mean more than just a smart refrigerator that knows when we run out of snacks. And that will be interesting, right? Today, we are here to discuss the very innovations that will reshape industries, transform societies, and may even help us to find out why our computers crash right when we are about to submit our research papers. And I believe every one of us, we all have faced these situations. We have students over here, right? So for them, they'll get to know why their computers run out of their working right before when they are about to submit their assignments. Each year at GLS University is like a masterpiece crafted by our guiding lights. They offer us abundant opportunities to shape and color our experiences with ease and creativity. Our leaders, President of GLS University, Shri Sudhir Nanavati Sir, Executive Director, Dr. Chani Kapadia Ma'am, and Provost, Dr. Dharmesh Shah Sir, bring our aspirations to life, enabling us to create memorable moments like today. We are deeply thankful to them for their support and for giving us a platform to carve our legacy for future generations. This grand conference has been meticulously organized by two leading departments of GLS University, the Faculty of Computer Applications and IT and Faculty of Engineering and Technology. So let's give a big round of applause to all those without whom today would not have been possible. Before we proceed, let me invite the dignitaries and special guests to join us on the stage. I humbly request Dr. Anil Bharadwaj, Sir, Director of Physical Research Laboratory, Dr. Chani Kapadia Ma'am, Executive Director, Dr. Savita Gandhi, Dean FCIT PG, Dr. Harshal Aroka, Professor and Head FET, Dr. Tripti Doria, Dean FCIT UG. Let us all give a big round of applause as they join us on the stage. As it is the tradition in India, let us begin this auspicious day by invoking the blessings of Goddess Saraswati, the embodiment of wisdom, knowledge, and creativity. I would now like to invite our dignitaries, and with a special request, I would like to invite our Provost, Dr. Dharmesh Shah Sir, to join the members on the dais for the lamp lighting. I would like to introduce our Dean of FCIT PG, Dr. Savita Gandhi, as she is going to give the welcome address. Dr. Savita Gandhi, a distinguished academic and researcher, currently serves as the Dean of Faculty of Computer Application and IT at GLS University, having previously held the position of Professor and Head of the Department of Computer Science at Gujarat University. With 45 years of teaching experience, she holds an MSc and PhD in mathematics and is an associate member of the Actuarial Society of India. Her academic excellence is marked by several awards, including a gold medal for her MSc. She has published extensively, contributed to ISRO-funded research projects, and developed e-contact for UGC's e-PG Pathshala. Dr. Gandhi's vast experience and research contributions make her a highly respected figure in her field. I now request Ma'am to give her welcome address.
Good morning. So, good morning, namaste, and hello everyone. On behalf of GLS University, it's my great pleasure to welcome you all to the first international conference on advances in smart computing and applications ICASCA 2025. This prestigious event organized by Faculty of Computer Applications and Information Technology and Faculty of Engineering and Technology makes a significant milestone to our academic community. This year's theme, Intelligent Future, Transformating Computing and Applications, sets the range for insightful discussions, fostering innovation and collaboration. ICSC 2025 is being held in a hybrid mode. Our participations are from across all over the states from India as well as around the world, both on-site and off-site. Persons have joined virtually and persons have joined physically here with us. Your presence reflects our shared commitment to advancing research and innovation in smart computing. A key highlight is that all accepted and presented papers will be published in the prestigious Springer Communications in Computer and Information Sciences CCI series, underscoring the academic rigor and global impact of the research presented here. We are privileged to have esteemed experts who have shared their insights with us. Today morning we had Dr. Rajkumar Bhuya's keynote address, who is Distinguished Professor and Director, University of Melbourne, Australia. Any idea how many citations he has for his research publications? Anyone? Guesswork? Don't see Google, okay? So without seeing Google, can you tell me, except the first row, how many citations he has? Any guesswork? 1,000, 2,000, 4,000, 10,000? He has more than 1.5 lakh citations. To be exact, he has, as on today, the citations are 157,835. And his H index is 171. A true pioneer in cloud computing. Our next keynote speaker after the inauguration is Mr. Maulik Bhansali, CEO, NetWeb Software, Gujarat, a leader of driving technology innovations in the industry. We also have tomorrow our plenary session speakers, Dr. Mohit Tohilaini from NITK Surathkal, Karnataka, and Professor Dr. Om Prakash Vyas, Dean Professor from IIIT, Allahabad. We deeply appreciate their time and contributions to making this conference an intellectually rewarding experience. It's my honor to welcome our esteemed chief guest, Dr. Anil Bhardwaj, sir, Distinguished Professor and Director, Physical Research Laboratory. Despite his demanding schedule, Dr. Bhavdas sir has graced us with his presence, and we are deeply grateful to you, sir. His remarkable achievements align perfectly with our theme of intelligent future. Recipient of the Vikram Sarabhai Medal 2024 by COSPER and the International Academy of Astronautics Basic Sciences Section Award. He is also a passionate advocate for education, having reached over 100,000 students and teachers through lectures and research programs. Initiator of impactful programs for underprivileged and girl students, benefiting over 30,000 students in rural areas. We are very much honored to have such an inspiring figure with us today. Although our esteemed President, Dr. Sudhi Nanavati sir, could not be with us in person due to his urgent commitments, he extends his warm wishes to all participants. Under his visionary leadership, GLS University has achieved new heights of excellence. In fact, this very month, we received the prestigious NAC A+ grade, a proud achievement for us all. Dr. Nanavati's dynamic leadership continues to guide us, expanding our global footprint and academic excellence. I would like to warmly welcome our pillars of leadership at this GLS University. Dr. Chandni Kapadia, Madam, Executive Director, a true leader and advocate for women's employment, empowerment, recognized by Forbes and Economic Times. She has been instrumental in building international collaborations at GLS. Dr. Dharmesha sir, Provost and Professor of Finance, an energetic leader whose guidance keeps our academic ecosystem thriving. A warm welcome also to our Registrar, Dr. Dhruv Brahmbhatt, CFO, Dr. Shashank Bhandbhat, Deputy Registrar, Dr. Jainil, principals of different colleges affiliated to GLS, deans, directors, invitees, session chairs for today, HODs, and the entire GLS family, and including faculty of our faculty, HODs, administrative staff, and frontline teams. Your dedication behind the scene is invaluable. The conference stands as a testament to academic integrity and research excellence. The review process for the papers had a 5-tier system, and outcome was that only 22% of the papers submitted have been accepted in this conference. This itself talks about the quality and the rigor of the review process adopted under Springer guidelines. Every individual from faculty to frontline staff has contributed for making this event possible. Each, whether person be faculty of the department, whether be the admin staff, or whether be the lab staff or the frontline persons, they have worked from pillar to post to see the success of these 2 days conference. I may not be able to take the name and thank each and everyone, but I thank from bottom of heart each and everyone who has contributed to making this conference success. However, I must express my deepest gratitude to 3 individuals who have been instrumental from the start of the idea of hosting this conference and would continue to support till the proceedings are published. I would like to thank them in the public. The first one from Springer, Mr. Amin Mombashari, senior editor of the Springer Nature, for his trust in us, his guidance, and making the review process continuous. He guided us continuously to make the review process rigorous and adoptable. The second person whom I'd like to thank is Dr. Nirbhay Chaube. He is Dean, Ganapat University, for his unwavering communication and advice throughout this journey. And the third person who I'd like to thank is Dr. Prerna Agarwal, my colleague who has worked day and night with me managing every detail of the conference management portal and ensuring the success of this conference, apart from all many others who have definitely contributed to the success. In conclusion, I encourage all participants, both on site and online, to engage actively, share knowledge, and build meaningful collaborations. Let this conference, IACA 2025, not only be a platform for presenting research, but also a springboard for new ideas and future partnerships. Thank you, and let's have an engaging and inspiring conference together. Thank you very much.
Thank you so much, ma'am. Flowers are our way to express gratitude and respect. And with this, we will move towards feliciting our guests. Therefore, I request Dr. Chandni Kapadia ma'am to welcome Dr. Anil Bharadwaj sir. I request Dr. Savita Gandhi ma'am to welcome Dr. Chandni Kapadia ma'am. I request Dr. Harshal Arokar to welcome our Provost, Dr. Dharmesh Shah sir. Now I request Dr. Tripti Dodia to welcome our Chief Account Officer, Shashank Sas sir. Now I request Dr. Devashri Mehta to welcome our Registrar, Dr. Dhruv Brahmbhatt. Sir. Thanks a lot, everyone. It is with great honor and privilege that I stand before you today to introduce an extraordinary leader, a visionary, and a trailblazer in every sense, Dr. Chandni Kapadia ma'am, the dynamic executive director of GLS University. Dr. Chandni Kapadia's remarkable journey spans leadership roles across the US, UK, and Europe, where she managed teams and drove business success. Returning to India, she brought a fresh global perspective and played a pivotal role in bringing iconic brands like Calvin Klein, Starbucks, and Burberry to the country, shaping their success with their strategic foresight, innovation, and deep commitment to excellence. Dr. Chandni Kapadia's entrepreneurial brilliance has earned her a place among India's most distinguished leaders. She has been recognized by Forbes as one of India's top 10 women entrepreneurs, which accolades from the Economic Times, Oxford University UK, Zee Business, and the Times of India. She has been felicitated at the prestigious House of Lords and honored with the Black Swan Award for Women Empowerment by the UN Global and the Government of India. Her impact, however, extends far beyond business. Recently named one of Time's 100 most influential people in the world, Dr. Kapadia continues to be a catalyst for change, a champion for women's empowerment, and an ardent advocate for compassionate leadership. And now, adding another remarkable milestone, she has been featured in India Today's prestigious special issue, High and Mighty, The Ultimate Power List 2024. Let us all give a huge round of applause. Congratulations, ma'am. Being recognized among India's most influential leaders is a testament to her relentless pursuit of excellence, innovation, and transformation. Her clear vision, boundless energy, and unmatched commitment are reshaping the landscape of higher education here at GLS University. We are incredibly fortunate to have you, ma'am, leading us towards a future filled with growth, progress, and excellence. I hereby request, ma'am, to address our audience.
Thank you, Hirva, for such an elaborate introduction. Good morning, everyone. Yes, it's still morning. Especially to the people that we can't see, but you can see, as Savita Ben just mentioned. When I walked into this room, I was wondering why half of it is empty. Normally, it is not. And I was like, oh my God, is this the only people that we have for this conference? But then I realized that there are many more watching us through YouTube or whatever it may be. And so a very warm welcome to everyone who's online. Dignitaries on the dais, my colleagues at GLS University, my provost, Dr. Dharmesh Shah, Shashank Shah, CFO, my deans and directors, faculties, researchers, and of course, my dearest students. It is truly a pleasure to stand before you, such a distinguished gathering of academicians, industry experts, researchers, and of course, those very young minds, innovators at GLS University's first international conference on advances in smart computing and applications. Let me call it ICASCA-2025. This moment is particularly special for us as we welcome you all to Ahmedabad's first ever Springer Conference, hosted at a university who has just got the NAC A+ accreditation. So a huge round of applause for that. Which reaffirms our commitment to academic excellence and impactful research. We have with us Dr. Anil Bharadwaj, Director of the Physical Research Laboratory, a distinguished scientist who has contributed to planetary atmospheres, has not only enriched scientific knowledge, but has also inspired generations of researchers. He has played a pivotal role in NASA's endeavors and even milestones like Chandrayaan-1 and 2. And now I even understand Chandrayaan-3. Feats so monumental that in my humble intellect struggles even to understand and grasp them, forget making them. For me, it is just rocket science. I was mentioning him to that. I wouldn't understand anything. Nothing short of eighth wonder of the world for me. You know, at GLSU, we have always believed that true learning happens when innovation meets curiosity, critical thinking challenges the norm, and collaboration fuels progress. And ICASCA 2025 is a testament to the excellence today. The incredible response we have received with research papers pouring in from across India and even beyond our borders, with participants joining us from, of course, Gujarat. We have Andhra Pradesh, Tamil Nadu, Maharashtra, Odisha, of course, as Vietnam as well, is proof that smart computing is no longer an emerging field, but it is shaping our present and designing our future. And with an acceptance ratio acceptance ratio of less than 30% of the research presented here, isn't that just impressive? But also the very best, pushing the frontiers of knowledge in ways that I'm sure will leave a very lasting impact, not only on research, but also on the applicability and ease and use of technology. A big congratulations to Savitaben Gandhi, Harshalbhai Arolkar, and Tripti Rodia for a massive response and participation to this event. As Matt Mullivan rightly said, technology is best when it brings people together. And that is exactly what ICASCA 2025 is all about. It's not just sharing research, but it's building connections, exchanging ideas, and creating collaborations that will shape the future. Whether you're here as a researcher, an industry expert, or a student that is stepping into the world with curiosity and ambition, you are now a part of something much bigger, a global movement towards a smarter and a more connected world. The theme of this conference, Intelligent Future, Transformative Computing and Applications, could not have been more relevant. We're living in an era where AI, machine learning, edge computing, quantum computing are no longer concepts of the future. They're actually shaping our present. From AI-driven medical diagnostics that claim to predict our health, to smart cities that promise efficiency, we still can't figure out the problem of the traffic jams. We can't solve that. But even then, technology isn't just evolving, it's rewriting the fabric of our lives. But as exciting as these advancements may be, the true magic not just lies in reaching the final goal, but actually the pathway towards it. The journey of discovery itself is the most exciting. Looking at the brilliant minds before me, I can only imagine the thrill and yes, the occasional frustration that you might experience. While the rest of us all over here trying to use AI without sounding robotic, the pioneers and architects of this revolution, you guys, must feel like a cosmic cheat code to a new reality. We're still in our formative years of the AI era, learning how to harness its potential, while you guys are already pushing its boundaries. So as you navigate this conference, remember, it's not just about the answers that you find, it's about the process of exploration, curiosity, and learning, and truly that shapes the future. So honestly, enjoy every step of this incredible journey. And of course, with great advancements come great responsibilities. As smart computing takes over every aspect of our lives, the need for ethical AI and cybersecurity isn't just a fancy add-on. It's a necessity. This conference isn't about just showing off what you've done, what you've achieved, your innovations and algorithms. It's about making sure that we don't create a tech monster that we can't control. After all, you are the masterminds behind smart technology. But let's not get too smart into scamming people with identity theft, with financial fraud. We've seen enough of those. The vanishing act stories, I'm sure I don't need to get more into that. Remember, you are all a part of a shared mission to make technology not just smarter, connected, but that's all what ICASCA 2025 is all about. It's not just throwing big ideas, but actually turning them into real impact. Let's be honest, who wouldn't want life to be easier, smarter with technology and making our life easier? We all need that and want that. So as you embark in these 2 days of insightful discussions and groundbreaking research, meaningful collaborations, I encourage you to all engage deeply, question boldly, and innovate fearlessly. After all, the future of smart computing is not something that we merely observe, it is something that we shape together. So make the most of these opportunity, push your boundaries, leave here not just with ideas, but with motivation and turn them into reality. I hope you have a great time at our campus. Welcome to Ahmedabad. Welcome to GLS. Again, a big kudos to Savita Ben Gandhi, Dr. Harshal Arolkar, Dr. Tripti Dodia, and their team, FCAIT, for this theme and for this event. I wish you all the best. Welcome to ICASCA 2025. Let's build an intelligent future all together, one idea at a time. Thank you.
Thanks a lot, ma'am, for fueling up our energy. Now, moving towards the address by our chief guest, I would like to take a moment to introduce Sir. Professor Anil Bharadwaj, sir, is a distinguished planetary and space scientist with an illustrious career spanning over 3 decades. He earned his MSc from Lucknow University in 1987 and his PhD from the Indian Institute of Technology, Banaras Hindu University, in 1992. He joined the Indian Space Research Organization in 1993, where he has been a driving force behind the development of planetary science programs. Professor Bharadwaj's pioneering contributions include leading the SARA experiment on India's first lunar mission, Chandrayaan-1, and the Menka experiment on the Mars Orbiter mission. He has also been instrumental in key experiments for Chandrayaan-2, Chandrayaan-3, and the solar mission Aditya L1. Currently serving as the director of the Physical Research Laboratory, since 2017, Professor Bharadwaj's research in planetary sciences, X-ray astronomy, and solar system exploration has garnered international recognition. His work includes the discovery of X-rays from the rings of Saturn, X-ray flares from Jupiter and Saturn, and significant advancements in our understanding of aurora and air glow emissions in planetary atmospheres. With more than 220 peer-reviewed publications and numerous prestigious awards, including the Shanti Swarup Bhatnagar Prize 2007 and the Infosys Prize 2016, Professor Bharadwaj's impact on space science is profound. He is an elected person in all 3 national sciences academics in India, and his leadership extends to international scientific committees and journals. His recent accolades include the 2024 Vikram Sarabhai Medal and the International Academy of Astronautics Basic Sciences Section Award. Beyond his scientific achievements, Professor Bharadwaj is deeply committed to public outreach and education, having inspired over 1 lakh students and initiated programs for underprivileged and rural youth. His story is featured in various publications, and he is celebrated as one of the 100 great IITians dedicated to the service of the nation. I hereby request Sir to address the audience, and please give a big round of applause for him.
First of all, thanks for a very generous introduction and a pretty long introduction. Namaskar, Suprabhat, Kem Cho, Jai Shri Krishna, Khambagadi, Adabars, Vanakkam, Ram Ram, Radhe Radhe, Sat Sri Akal, a very good morning. Dignitaries on the dais, off the dais, the faculty of GLS University, the functionaries, the distinguished delegates, students, ladies and gentlemen. Let me first of all compliment GLS for organizing this first international conference on advances in smart computing and application. In short, ICSA, or I say, how you say? ICASA or ICASA. And also for inviting me. And as you must have already seen who I am, you must be wondering what I'm doing here, right? Why I'm called? Because I'm not a computer scientist. I'm not a AI person. But if you look at the world today, two words which are called buzzwords. One is quantum, and you add anything to that. Like quantum computing, quantum metrology, quantum communication, quantum dots, quantum materials, and whatnot. All started with quantum mechanics as the base, discovered by Schrodinger through a very basic equation. And that has made a fundamental change in our understanding. And therefore, when we talk about quantum materials, we also talk about nanomaterials. And there is a sea change in our understanding of how material behaves when they become very, very small. But for quantum, you need something else. And particularly, this conference is focused on smart computing with the theme of intelligent future, transformative computing and applications. So now you are moving from bits to qubits, right? When you talk about quantum computers. And we are talking about bringing in revolution of how we can increase the speed at which we can do computations. Secondly, as I was just told about cybersecurity by madam, we believe that quantum communication is much more secure than our conventional communication means. And this is essentially because if you want to hack, it becomes enormous amount of requirement for you to do the hacking. And that's why we say that quantum communication becomes much more secure. And a lot of countries, including India, is now working on bringing quantum communication. And not only quantum communication, but also satellite to ground quantum communication, where ISRO is actually working now. Very recently at PRL, we demonstrated how quantum communication can be actually used in a free space, where we demonstrated over 200 meters, a communication which cannot be hacked. And then, with help of Department of Telecommunication, through a project, we demonstrated that this can be combined with fiber optics and did a quantum key, which is a key to this quantum communication, which is called QKD, quantum key distributions. And there are different algorithms of doing it and how do you do that. We demonstrated that this free space quantum communication can be combined with fiber optics quantum communication. It was demonstrated in Delhi by developing the key and doing a free space over here. And this was demonstrated to Principal Scientific Advisor to the Government of India. Now, let us talk a little bit about AI. AI means artificial intelligence. So, intelligence is there, but it is artificial because it is done by humans only, right? So, don't think that AI is something very, very different. Look at the word artificial. It is intelligence built into a system by humans only, right? But sometimes we say that AI is going to be a trouble for all of us because it can think of its own. No. The knowledge which you give in terms of code only is the one which is available. It can make permutation combination very fast to decide what to do. And this brings to how we are using AI in space. You know, the Mangalyaan mission, the Mars orbiter mission of India, when we are designing it, there was a serious issue. The serious issue is the communication time, or you say the light travel time between Earth and Mars is as short as 4 minutes and as large as 24 minutes. So if somebody is there on Mars, like our Mangalyaan, Mars orbiter mission, and we say, hello, how are you? You have to keep waiting for several tens of minutes to get the signal back telling, okay, I am fine, thank you. That means my satellite has to be smart to know what to do in case of any trouble. That means I have to now build my satellite which takes decision of its own. So we started using AI in space quite some time back. We had the launch of the Mangalyaan in 2013 on 5th of November. After traveling for 10 months, it reached Mars and got inserted into an orbit around the Mars in the first attempt, making India the only country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. And it was planned to be working for only 6 months. That is how the planned lifetime of a satellite is. But it worked for more than 8 years. And it sent us a lot of information about the Mars. I'll give you another example. I believe all of you must have watched the Chandrayaan 3 landing, right? 23rd of August last year, right? At around 6 p.m. in the evening. Whole India was watching TV, looking at the Chandrayaan 3 landing, the Vikram lander landing. It was an autonomous landing. Autonomous means no command control given to the lander when it started landing. It was a terror for 15 minutes for all of us in the mission control. Right? We were holding our breath to see that it lands successfully, the Vikram lander. But nothing is in our hand. It is left of its own, but intelligence is built in for deciding where to land, whether the landing site is safe. So onboard computer was made AI enabled. Lot of algorithms, because you see it is a live engine working, right? And it is seeing, sending photographs inside, processing and deciding where to land. It has given a landing area. Okay, this is your landing area. But there also where to land, it has to decide. And it has to see that I should not land on a boulder or a crater. So that means the processing of images happening live on a lander. Engines were being fired. Velocities, acceleration, deceleration, angle, everything is being computed online and fed to the computer of the lander to say at what speed I have to move. Where I have to go is known, but how I have to go is decided by the lander. And then there is a phase, because when we start from the orbiter is going like this, right? Isn't it? So when I start, it will be in this form with 4 legs like this. Then it has to become slowly vertical because it will land on the surface, right? And then there was a built-in period of hovering. Hovering means I have come almost like 100 meters above. I have to now see the best place to land. So I stand at one place, calculate myself where I am, and I see around and see, oh, this is the best place. And then I move around there and then. This is the intelligence which is built into the lander. And that is how India became again the first country to land near the south pole of the moon. Right? So when we are talking about AI, again I say it is artificial intelligence. So we built in all the possibilities of what decision the Vikram lander has to take. And of course, after landing, our job starts. Means we, the scientists, because we had instruments on the lander and instruments on the rover. So our job started after the landing was over. And we said, okay, now let us do the science. We had instruments developed in PRL, in the lander, and we had instrument developed in PRL on the rover, which moved for 10 days on the lunar surface and sending us data through the lander to the ground. And this was all possible because of very fast communication which is happening between Earth and the moon, because it is only 2 seconds. So we are almost like live controlling the rover moving onto lunar surface. But it is not possible in the case of Mars because light travel time is so large. So that means if we are to start exploring different planets which is little away from Earth, then you have to make your satellites very, very smart. And that's why I'm really privileged to be here with all of you and to look at how the advances is taking place. I was just going through this sheet of what kind of papers are being presented here, and I was really delighted to see that a lot of young brain, and I can see that I think 75% to 80% are lower than 30, 35, right, in the audience, which in turn suggests very clearly that the future is very bright in these areas. And of course, the woman power you can see over here, right? And of course, in the audience also, which means that we have manpower, we have human resources available within the country. And that is what has to be used for the benefit of society and for humanity. And as Madam has already told you, that you have to be honest and ethical to the society, which is very, very important. As the science grows, there are always pros and cons of every technology, every discovery which happens, but we have to take in the best possible ways to help the society. And once again, I compliment GLS University for organizing this conference and in particular calling me over here. Thank you. Thank you very much.
Thank you so much, sir. Now that the stage is set, both literally and intellectually, we are ready to dive into the heart of this conference. Over the next 2 days, we will explore cutting-edge research in areas like artificial intelligence, data science, smart computing, and more. As we march towards an intelligent future, one where computing will not only assist but transform human life in ways unimaginable, I hope you all leave this conference with more than just notes. You leave with ideas that could change the world. Now, before inviting Tripti ma'am for the vote of thanks, I would take a moment to introduce her. Professor Tripti Dodia is associated with GLS University since 2000. She has 24 years of teaching experience. A bachelor in computer science engineering, she has done her MSc-IT and PhD in the field of computer science. Her research interests span the fields of artificial intelligence, machine learning, and deep learning. She has attended a number of national and international conferences where she has presented research papers in the area of information retrieval. She has published several research papers in national and international journals. She has received Vaigyanik Drishtikon Award for her paper titled Recommender Systems for Diseases in Kids. She has authored a book titled Computer Organization and Advanced Microprocessor. She has also co-authored textbooks in the subject Computer Sciences for Standard 11th and 12th, Gujarat State Education Board. She has conducted several workshops on open source animation tools, artificial intelligence, and machine learning. She is the lead faculty in designing innovative syllabus of BCA as well as IMSc-IT programs, and also guiding other faculty members in maintaining standards of academic delivery. I now invite Dr. Tripti Dodia for the vote of thanks.
Thank you, Hirva. It's truly an honor and privilege to deliver the vote of thanks at the conclusion of the remarkable inauguration function of our conference. On behalf of Faculty of Computer Applications and IT and Faculty of Engineering and Technology, I extend my heartfelt gratitude to all those who have contributed to making this event a grand success. First and foremost, I would like to extend our deepest appreciation to our esteemed chief guest, Mr. Anil Bhardwaj, sir, for gracing this occasion with his presence and for sharing invaluable insights. Your words have not only enlightened us, but also set the tone for the discussions that will follow in the day ahead. We would like to express our sincere gratitude to Shri Sudhir Nanavati, sir, President, GLS University, who continues to inspire us to work with enthusiasm and dedication. So thank you for showering your blessings as always. I take this opportunity to heartily thank Dr. Chandni Kapadia ma'am, Executive Director, GLS University, for her constant support and guidance. Our sincere appreciation to Dr. Dharmesh Shah, Provost, GLS University, for his guidance. So we look forward for your continuous support in all future endeavors. Our heartfelt thanks to Dr. Dhruv Brahmbhatt, Registrar, GLS University, Shashank Bhai, CFO, GLSU, for their support and cooperation in organizing the event. Our sincere thanks to the deans, directors, heads of GLS for being with us today. A special thanks to our keynote speaker, Dr. Rajkumar Boya, who has enriched us with his knowledge and expertise. I would like to extend my thanks to Springer editorial team for their collaboration and support. A special thanks to organizing committee, technical team, volunteers, administrative and support staff, auditorium staff, and to all those behind the scenes for your tireless efforts and dedication. Your meticulous planning and hard work have ensured the seamless execution of the event. I also thank our delegates and participants for their enthusiasm and engagement. Your presence and active involvement will make this conference a platform for learning, networking, and collaboration. As we move forward with the sessions ahead, let us carry the spirit of this inaugural function and make this conference a fruitful and enriching experience for all. Thank you, everyone.
Thank you so much, ma'am. I would request everyone to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Today we have with us Mr. Maulik Bhansali, our esteemed keynote speaker, an entrepreneurial and driven chief executive with 22 years of leading industry expertise in founding, running software business in domestic and international marketplaces. Mr. Maulik Bhansali is a co-founder and CEO of NetWeb Software. He is also a vice chair of NASSCOM's National SME Council and a NASSCOM Executive Council member. Mr. Bhansali is also a founding member of TAI Vadodara and is currently president of TAI Vadodara. TAI is a global initiative for building a powerful entrepreneurial startup and ecosystem. He is the past chairman and director of the Gujarat Electronics and Software Industries Association and currently plays an advisory role at Cheshire IT Association. He is on the board of management and board of studies with several known universities. He is a frequent speaker at several professional and educational institutes and is a mentor to many young entrepreneurs. Today, he will be discussing about transforming AI innovations into business impact. Over to you, sir.
Thank you so much, ma'am. Am I audible?
Yes, sir.
Yes. All right. Thank you so much for having me and good afternoon. Firstly, my sincere apologies. I could not be there in person. I was to be there, but because of some health issues, I could not make it in person. But I'm extremely delighted and so happy to be joining you all online. And I hope I'm able to kind of share some insights, some thoughts, my views into the current scenarios and the research innovation angle of it, and of course bringing that to the business impact. Right? I hope I'm audible, friends. Am I? Oh, thank you so much. That was really good to know. Ever since we are talking about innovation and since you're talking about research, I believe we must be having in the audience there students, research professors, researchers, I believe, and there may be some online listeners as well. But am I right in my understanding? Yeah. Am I right in my understanding, friends? Okay, thank you. I'm trying to, though I'm really remote, I'm trying to a little bit more interactive. So excuse me if I ask some such questions to see that I'm connected and that you all are also with me as I speak. Uh, you know, uh, so this is we can go to the next slide, friends. Can we please go to the next slide? Okay. So now let me tell you something about what's happening today. Uh, you know, we all are living in an era which is very rapidly changing, and we all see that happening around us. We read about it, we understand it, we try to use it, we try to experience it. AI is one such big thing happening around us, with us, and we are all part of it, whether we believe it is going to be directly useful to us or not, but we are certainly impacted by it, right? And it is advancing very rapidly, and so rapidly that sometimes we do something and it is way behind, even after thinking about trying to apply it somewhere, but the target has moved by then, so it's a moving target if you think about it, and it continues to move, right? So what happens is, several times we come up with some idea or some concept, and by the time we really bring that to fruition, the target is somewhere else. It has moved, right? So that's the scenario. The second thing is, at the same time, friends, if you notice, until now, wealth was generated by doing the known things, right? Which means you know something and you do it again, possibly with slight improvisation, you possibly have an idea which will generate wealth for you. So you are actually doing things by or seizing the opportunity, or having the opportunity of generating wealth by doing the known things. So far, not anymore. We are in the era where we are now generating wealth by seizing the unknown, right? So it's like you do not know what's next, and you have to still have your hands around it. Okay, so that's what is happening, friends. Okay, now to be able to really understand these two aspects. So we talked about two things. One is innovation on technology, innovation on AI. For example, I'll speak around AI a bit, and then what's really required around in terms of business, in terms of how we think wealth has been generated so far, right? You cannot work in isolation on two different points. You have to bring these silos together, right? And the challenge is actually making sure that these innovations and these concepts are really brought into the real world, and that's really very, very important. And the challenge is actually moving from small little concept to a scalable, implementable solution. Okay, we will try to possibly talk about that in terms of how we can achieve that and how we can do that. All right, let's go to the next slide. Okay, this is very interesting. Like I said, that we need to kind of understand what we are really using a technology for, right? Let me give an example. I'll go a little back in the history, okay, uh, and I'll go all the way to 1890. What happened in 1890? In 1890, one of the greatest invention happened, okay, and that was Thomas Edison. Around that time, came up with the light bulb in electricity. Okay, now what happened with that? It was used as, of course, lighting the houses. Okay. But the adoption of electricity wasn't really, it did not happen overnight and in just few years, if you think about it. Okay. What happened as part of that, another individual who was working along with Thomas Edison by the name Frank Sprague, okay, he came up with a solution of using electricity, okay, to power the small factories. So factories which were running on steam, right? Steam were used to kind of generate the energy and actually run the shaft and shaft to the machine, right? Or to the gears and the machine. So it was steam which was used until then. He thought of replacing that as a solution or that energy of steam instead by using electricity. What happened? It was a point solution, as we call. It's called a point solution. The reason why it is called a point solution because it actually changed the point of energy. So instead of steam, he replaced it by electricity. And that was running the shaft instead of the steam. Okay. With that, what happened? It certainly did help in saving the fuel, which was the idea. Okay. But the real revolution didn't happen even after that. Of course, the small factory owners, the small shop floor owners did use to an extent possible to replace their steam energy to electricity. But it still did not bring the outcome as what we see happened over the years. What happened next? So that was a point solution. The reference to point solution is very important, friends. Why point? Because a point of energy was replaced and it was replaced from steam to electricity. This is called point solution. The next stage came where instead of the point solution, a thought came in as application solution, right? Think about this. Why application solution? That instead of now replacing the steam with electricity, okay, how about actually decoupling, meaning cutting the source of energy to the application of the energy, right? So what happened? Instead of just driving the shaft, okay, what happened? It started actually, someone decoupled the source from the application, right? So here the application is shaft. Instead of bringing it closer to source, it was decoupled. And with that, you could actually take the energy, which is electricity, to smaller different units, okay? And the smaller different units can then be powered to run, okay? So what happened in process? You then had things like applications like motors, for example, which were installed separately into smaller factories, and then they started powering the individual machines, which could actually function independently, right? So what happened by that? You could now actually bring and reduce the energy loss which was happening just by running the shaft to different applications, right? So that's called the application solution. That's what next happened. With that too, of course, it did help, but it still did not bring the revolution as we saw later. What made the difference was thinking differently that, how about bringing this solution or application solution to a different level, which meant bring it to a system level. So what happened? You could now have individual motors running in different sets in different, in individual machines differently sourced and kind of bringing electricity to different machines. And then this machine's running independently. But then someone thought of that, how about now bringing these machines to run with each other, right? That's when Henry Ford thought of an assembly plant for the first time, and he had this automobile industry by the name Ford and Ford Motors, right? So think about it, replacing your friends, we are seeing similar outcome even with AI. You thought of AI as in something which will only help you do a prediction for one such need and one such requirement, right? Yes, so it does. But today what we are seeing is decoupling, prediction from the decision making. Okay, so you have prediction and you have decision making happening in two different steps, right? And with that, what we are now seeing is emergence of agentic AI, as you would have heard of, right? What happens here? Again, if you think about it, we are bringing one single power of prediction, decoupling it from decision making, okay, and then empowering the solution in form of smaller little agents coming together or AI agents coming together. And you can then think of a workflow, okay, which is actually coming together, and you can run your business workflow through smaller little agentic AI. What I was earlier citing an example of analogy of what happened with the electricity and the source of energy cutting to application, taking it a little differently and distributing it, is what we are similarly happening in the field of AI as well. And that's where we are seeing emergence of agentic AI to be able to enable the business workflows. And if you collect these agents of AI doing different tasks, which are built around, let's say, specific LLMs or SLMs or small language models, you are able to then achieve a larger, impactful workflow, which is more relevant in terms of business transformation. And that's the impact that we are talking. So therefore, in my honest opinion, it's important to not just think about what can AI do, but it's about what business problems can AI solve. So I think our research focus also has to be more from the market relevance point of view in terms of what business problems can AI solve instead of what can AI do. And I think it's not something which is new to all of us, but several times as we work in our labs, we forget about the real business needs and we just go after academic exercise or explore technology in isolation without understanding the relevance of it and the real applications of it. So I call upon a strong collaboration with industry partners to align AI with commercial needs. And that's very important. Okay. Building industry academia collaboration is about to ensure that AI research meets commercial demands. And of course, there are ways of doing it. I'll give an example. Okay. And the reason I'm referring this example is because I have experienced it at our own business. A few years back, we had received a business case or use case to be solved from one of our existing customers. Okay. And this was related to computer vision at that point of time. And by using computer vision, a specific problem had to be solved. Now, this was easily about 9 years back. Okay, not about 5 or 6 years back, about 9 years back. And at that time, unfortunately, we couldn't really find much of help from our own people. And we couldn't even, if we wanted to recruit, if we couldn't even recruit good people knowing about it and knowing enough about it to be able to bring that into a business application. Okay. We tried very hard. We also called upon several academia to see how possibly we can do. Interesting enough, instead of finding professionals, we found research professors who were working in computer vision. Okay. Now, with that help, we could actually develop a proof of concept along with those professors to be able to bring that into a real business application. To my understanding, it was more of an it just happened. We did not think of that. We in fact thought of that we'll be able to possibly find some professionals, some students, or some some experienced people out in the industry who have done that. But while doing that, we came across research professors who have done that and possibly have done some have written some research papers into that direction. We came across that. It was not an idea that we thought of to approach professors or research professors in the first place. With that, what happened, we could actually do a proof of concept along with them. Secondly, what we needed was also a pool of people who would then actually take it forward. So what we could then do with the help of these research professors, we could actually create a problem statement to be hacked. We created a hackathon, okay, whereby we invited close to 60 students under these professors to be able to work on this problem to be hacked. With that, out of 60, we found at least 5 came very close to solving the problem. And that's where we figured out the interesting model of not just working alongside with the professionals or the students and get them on internships, for example, but also work very closely with the research professors and have their research talent put to or leverage that to the use and to the real world application. Now that's a model which I truly admire and I truly live by, and we truly live as we are further exploring those possibilities even in our own business. Okay. But today, if I want to look at where are such research professors available, there is no single database today available in the country, unfortunately. And if there is one, I'd be very happy to know that. To be able to figure out what these research professors are capable of, what research they can take, what is a commercial side of that research that can bring out to, and mapping that. If we possibly have that today, and if we can take that up, and maybe if your university can take that up, that'd be a great and huge advantage to your university. And of course, the kind of resources that you bring to the ecosystem around and to the country at large will be immense. Because industries like us look for such opportunities to work along. Now, today we do not have that source. And if we do, I do not know, in which case it has to be made visible. Okay, so I strongly recommend that to be able to do so. Another interesting point is we have to move from theoretical research to practical implementation, right? So several times we talk about things like proof of concepts, right? Industry does not need proof of concepts anymore because industry wants faster adoption, industry wants faster implementations, and even if failing, fail fast, right? So that's what industry is looking for. So what we're talking here, we are looking for proof of value instead of proof of concept. And that proof of value will not come unless and until you take it up to the level of MVP, or how most of the startups work, by implementing minimal viable product. So even the research has to take it forward more than just putting it on a paper to be able to take it out to the proof of value instead of proof of concept. Can that be done? Of course, I'm sure it can be done. So run pilot projects with business partners before you think of converting that into a proof of value. And there are some startups, I know some startups which are running along and are incubated with NASCOM Center of Excellence, okay, which I'm part of. Have partnered with small factory, for example. A startup has partnered with a small factory to test AI predictive maintenance, reducing machine breakdowns, and that has resulted breaking down instances, breakdown instances reduced and down by 40%, leading to a commercial adoption. So I think just working in isolation doesn't really help. It does help in terms of bringing clarity to the concept, okay, or bringing innovation to the concept itself. But that innovation is of no use until and unless it is worked along with the adoption of it and along with an industry or business partner to be able to bring it to a proof of value more than from proof of concept. So I think in my honest opinion, that's my recommendation, that all our initiatives, all innovations, all research initiatives must think of proof of value instead of just proof of concept. And that's an additional effort, but that can certainly be brought together by working along with an industry. Or if you cannot directly work along with the industry, please do have an angle or at least a model of center of excellence wherein you can bring in the research, you can bring in the industry needs and marry that together and make sure that you are now bringing that concept to proof of value out of that center of excellence, and that proof of value then can be brought to the larger use for the industry or for the adapted. NESCOM's center of excellence, and there are many more such center of excellence, are real good models to adapt to. Addressing problems alone doesn't really help. We are sitting in times where we have to make sure it is addressed in an ethical form, right? So even if you have a proof of concept, unless and until you think of implementing in a transparent way, in an unbiased way, in an explainable way, you will not get the industry trust. So alongside bringing the proof of concept, as far as AI is concerned, one also has to understand that what are the transparent and explainable compliances that one should really bring into along with the research angle, right? For example, a fintech startup, okay, which I know very well, developed an alternative credit scoring model, okay, overcame regulatory pushback by making AI more explainable in nature. Because when you talk about fintech, for example, okay, or when you talk about health tech, for example, your models have to be explainable enough such that industries can really adapt to it. Therefore, addressing these regulatory needs or overcoming this regulatory pushback is the need of the hour. And unless and until your research or your AI models, for example, are explainable in nature and are unbiased, it does not really help. So, for example, think about how you are having different data sources in your AI model and not just one. If you have just one, possibly it may be biased, right? But can you have unbiased data models by bringing in more data sources and creating the data stream which is more unbiased in nature? And that's the need of the hour. Can that be part of your research areas? In my honest opinion, it must be, because unless until you have that, the industry adoption really would not really happen. It's also important to understand that one is able to kind of bring you research into a viable commercialization as well. That angle of commercialization is very, very important, okay? Because unless until you have angle of commercialization, it is not sustainable. So no matter what you think, no matter how you think about your research, if it is thought in isolation, it's not right. So one has to think about the business applicability, as we talked before. And second, alongside comes the commercial business model as well. So can you have, for example, an AI service just like software as a service? Can you have AI as a service? Is that possible? Can you do that? Think about that. Can you license your AI technology or your technology that you have come up with? Think about that. If you can bring your proof of concept to proof of value, okay, then it is licensable technology as well. Because most of the times in the industry, when you come up with an innovation, industry thinks about the applicability of it. And the applicability of it comes with the clarity in terms of how it can be applied. So therefore, the licensing of that technology, possibility of that can only happen by having proof of value and not just proof of concept. So if you work early on with a business along with your research idea, or whether it's your or with your innovation, the more opportunity or the more probability you will have in terms of making it more licensable. And the moment you have licensability of it, you will have value that you have created around your research. So I think it's important for all of us in the academia as well to be able to see that your research is having a commercial value. And that commercial value can only happen if you are able to prove it by a proof of value. Now, several times it's equally important to understand that we all need funds. We all need grants, government grants, corporate funding, many times angel investments, right? It does not come unless and until we have proof of value. So your research angle, again, I come back to, has to be from a viable business model, not just remaining more from a concept point of view, but from this applicability point of view. I'll give an example. One of the AI labs that I know, which specializes in NLP, it specializes in NLP, natural language processing. Okay. they licensed their technology of speech to text to call centers. Now it was so useful to them, but they could actually only do it by presenting the proof of value and not just the concept. Now that, if you think about it, has created a recurring revenue stream, not just for that call center, but for that AI lab. So what that AI lab did at the early stage of their NLP concept that they were coming up with, from speech to text, they connected with the business like call centers, customer support centers, to be able to see the practical applicability of it. And then they licensed it after proving the value. Once they started licensing it, the business started implementing it. As part of that, business made some fantastic revenue and they continued with that revenue stream. And the AI lab is also benefiting out of it. So that's a very, very good, sustainable business model for research as well, because research cannot happen on its own. Even for your research, you would need funds going forward. How do you do that? How do you make it sustainable? You can get grant for some time, but going forward, how do you sustain it? Unless and until you commercialize your research angle, it will not happen. So therefore, make sure that your concept is also having sustainable business model around it, and that can only happen by means of bringing early on pilots, early on industry adapters, or co-creation. Several times if you innovate yourself, it doesn't work. Several times if industry innovates themselves, it doesn't work. So time is about to co-create, and that's where it's very, very important. However, we need to have clear metrics to identify the success, right? And what are the success? I mean, as such, the industry will look at the success in terms of revenue growth or cost reduction or efficiency gains and customer satisfaction improvements, right? So to be able to get this or to be able to get near to this, your research or your concept or innovation, you can start early on by thinking from these four parameters, that your outcome, can it be tangible success? And there are indicators of tangible success. Number one, can it lead into a revenue growth? Can you lead into a cost reduction somewhere? Can it lead into efficiency gains somewhere? Or can it lead into customer experience? Now, these are the four indicators which are most of the times referred for adopting any innovation inside. Okay. And friends, innovation at our own end, for example, we have used AI for marketing. Okay. By that, we saw that there is higher engagement of 20% and 15% increase in our inquiries. What I'm trying to drive, that we need to start with real world business challenges and not just technical innovation. We need to build industry partnerships to ensure AI commercialization. We need to focus on scalable, explainable, and compliant AI solutions. Develop monetization strategies or business models such that you can continue with your research and its sustainable AI adoption and sustainable business adoption. And then, of course, as academia and researchers, you can also partner with the businesses to train and to upskill to maximize its impact and outcome. Some initiatives in India we already have been making, like there is an India AI mission by METI and with NASCOM. India AI portal also runs what is called as Lab to Market, which does what we talked about. But we need to kind of think more, and every university or every academia or every research organization has to really work around that and work further more on that. So, friends, I end my talk here. I'm sorry for a few glitches that were there in between, but I hope I'm able to kind of give a sense of what I meant by bringing innovation and of course converting into a business impact. It's not the same as you talk in person when you are there, but I try to do my best being remote. At some point of time, if I have an opportunity, I'll be very happy to come there in person and interact with you all. Thank you so much.
On behalf of JLS University, I would like to express my heartfelt gratitude to our distinguished keynote speaker, Mr. Maulik Bhansali, for his inspiring and enlightening address. Your esteemed insights and expertise have significantly enhanced our understanding. We sincerely appreciate your time and contributions. Thank you very much, sir, for the wonderful session.